Hello, Psychology of Learning students. Well, you've made it through week one, yay, and now you're on week two. For this week, we want to focus on chapter two, and chapter two really discusses research methods. Dr. Stephanie Stern, who created the PowerPoint slides that we'll be going through today and that we're going through in much of the course, the PowerPoint slides were made by Dr. Stern, and she renames this chapter Research Methods, and I think it's very appropriate. Um, uh, you need to understand the methods that have been used and that we continue to use to gain the knowledge that we have about learning in order to put this knowledge in its proper place. So if you don't know how we came to know what we know, then it's hard to judge how true what we know is. And so this is a very important part of the course. I have yet to see a Psychology of Learning textbook that doesn't cover research methods. If not the first chapter, then the second chapter. It's fundamental, foundational to going forward in the course. So without further ado, I'm gonna go share screen and let's look at the PowerPoint slides for this chapter. So then your book titles this chapter, The Study of Learning and Behavior. Dr. Stern retitles it Research Methods. I love her title better. I think she's absolutely correct. And I'm going to have two videos on this. This first video, it covers sort of the first half of the chapter, talking about the assumptions of behavior and how we measure learning, how we measure change. And then the second video will cover the methodological approaches that are discussed in the book. So to begin, we want to talk about the assumptions. And it's important to talk about these assumptions because when we use the natural science approach, it's based on these four assumptions. And if you believe any four of these are not true, then really you can't buy what we're selling. You can't think then that the information that we've gained through science is accurate. You're going to say that this is part of the story, but not all of the story because these assumptions are inaccurate. So one of the things that we definitely believe to be true, but it's just an assumption, is that learning is a natural phenomenon, that it's something that happens in nature, it happens naturally. And one of the first assumptions that we have concerning natural phenomenon is that that all natural phenomena have a cause. They don't just happen randomly. It doesn't just happen haphazardly, but there's something that caused this to happen. So when you go to take your first exam in here, we'll be measuring your learning in that first exam. Part of what we're assuming here is that learning didn't just happen on its own, that there were very specific things that caused you to learn. So some of those things you had control over, like did you read the textbook and then comprehend the material in the textbook? Did you have a distraction-free environment that caused you to be able to focus in on the multiple choice questions and select the answers? So one of the things that we assume is that certain things cause other things to happen. And this is true in all of the social sciences. So, I mean, when we go to explain someone's behavior, whatever it is, even things other than learning, we believe there's a cause that led to that. What becomes, and it's interesting and fun to try to figure out what those causes are. In fact, the experimental method we see as our gold standard method because it's the method that is best able to allow us to imply causation and to be able to figure out what those causes are of those behaviors. Another assumption we have is that causes happen before their effects. Causes precede their effects. So most of us sort of know that this is true intuitively. I'm going to give you an example that would be the opposite, and you'll kind of get an idea. It has nothing to do with learning, but you'd sort of get an idea. If I see a student in class sitting at the desk and I pop them in the nose and they fall back, those of you watching me do this, I would never do this, but watch me do this, would probably say that my punching the student in the face caused the student to fall back. How many of you would think, however, if all of a sudden the student fell back and then I went and popped him in the face, how many would say that my punch caused them to fall? No one would, because the cause came after the effect. The punch came after he already fell on the ground. So causes, we assume that causes come before the effects. And some of you, this is so simple, sometimes it's hard to know because you're like, that can't be what she means. Yep, that's what I mean. Most of us are very comfortable assuming this, but really this comes from Newtonian physics. And some of Einstein's work doesn't always imply this. And so it's definitely an assumption that we make with human behavior. Another assumption is that natural events include only natural phenomenon. So we need to identify the natural biological or environmental events that produce it. The last assumption that we're going to talk about, we call parsimony, huge big one. And this is that the simplest explanation that can account for all of the data is the better explanation. And psychology of learning has been affected so much by parsimony. So we can have, there have been theorists who've come up with big elaborate theories to explain different aspects of learning, different aspects of behavior change, but they weren't simple. And when simpler, less complex theories came along that could account for the same data, we said, okay, that first theory that's really complicated, we're not going to use it anymore. We're going to use this simpler, less complex theory. Now, the more complex theory we're going to use if it can better account for the data. So it's all about accounting for the data. But if all else being equal, keep it simple, stupid, that KISS mnemonic we use a lot. That's one of the assumptions that we have in science, that we have in psychology, that we have in psychology of learning. So those are the 4 assumptions. Now, knowing that everything that you're going to learn this semester, we know from using research methods that psychologists use that rely on these 4 assumptions, it's important that you also give some thought, real careful thought, to how we actually measure learning. And so to really bring this home, I'd like you to stop this video, and for the next 10 minutes or so, I'd like you to design a simple experiment. Try not to make it complex. Design a simple experiment. You're going to need 3 of them. Design an experiment for each of the following questions. So, do people learn psychology better by listening to lectures, like you're listening to this, reading their textbook, or both? So how would you design an experiment that would test that? Secondly, do 1st graders or 6th graders learn math the same way? How would you create an experiment that would test that? And lastly, can you train dogs and cats the same way? Can you? Try to think of an experiment that would allow us to test that. Okay, so turn off the video after you've come up with ways to perform those experiments. Turn it back on. So hopefully you had fun creating an experiment for each of those research questions. I find designing experiments to be one of the most engaging, interesting, fun tasks I can do. It seems to use my analytical mind, so it feels a little bit like math, but my creative mind, so it feels more like art and music. It just seems to merge that real analytical side of us with that real creative side of us. And so it's just so much fun. Of course, I turned it into my whole life, where up until I became chair 10 years ago, I spent almost all of my time doing research for a long, long time. And I just stopped becoming chair, and now I'm really looking forward to getting back into doing some experiments. So as you design those experiments for those 3 questions, one of the things that you had to do is figure out, how are you going to measure these things? So one of the questions, do people learn psychology better by listening to lectures, reading their textbook, or both? You had to figure out, how are you going to measure learning psychology? How are you going to, because if you're saying one group is doing better than the other, well, how are you measuring to know what's better? What are you using? We can think of this as a dependent variable. We can think about it as an effect. We could think about it as a measure of learning. So your textbook is wonderful about outlining some of the most common ways that the theorists and researchers in learning have used to actually measure learning, to measure change. What are the most popular dependent variables that are used in this field? So we're going to talk about them right up front here. So one of the huge ones that's used is errors. We look for a reduction in errors. So on your first exam, I'm going to look at the number of mistakes that you made. That's how I'm going to measure your learning. How many errors did you make? I'm going to look at the percentage of correct answers, which is just the opposite of saying the percent of incorrect answers, the percent of errors. So if I were to give you the exam right now, or maybe even the beginning of last week before you even read the first chapter, and then I give you the exam after we've covered the chapters that are on the exam, I would hope that you would make fewer errors when you took it the second time versus the first time. So errors is one way that we look to see how much someone has learned. Another avenue that we have is topography. And topography, we're sort of looking at the methods or the way that people do something. So like the way that a person dances, and their steps will change. Their even approach to dancing will change as they learn. I thought this man has an interesting, just 2-minute, real short video where he kind of goes over it in a funny way. So you can see how I hope that makes it more clear, a more entertaining way of explaining what topography is. Whoops, didn't mean to start that again, sorry. I'm having trouble getting to the next slide. Let me try another way. Okay, good. So, all right, another way, okay. Oh, so when you think about the experiments that you designed, that experiment where you were trying to see, do people learn psychology best from watching a video, from reading the textbook, or both? You might have used as your measure some errors. You might have decided to give people a multiple choice test after some who watched a video, some who read a book, and some who did both. Well, then you'd be focusing on errors. The second experiment that I asked you to think about was, do the first graders and the sixth graders differ in the way that they solve math problems? You might look at topography as your dependent variable for that. You might give first graders and fifth or sixth graders, whatever grade I said, a simple addition problem or a multiplication problem, and then ask them to solve the problem and show their work. And so let's say the problem was 6 plus 1. You might see that the first graders, maybe they take out coins, or they take out something that they can touch, or they mark like 6 dashes and then 1 more dash, and then they add them all up. You could see the approach that the 5th graders take is very different. So that would be topography, as using your dependent variable. Okay. Other measures that we have in dependent variable measures that are available to us: intensity. So your book talks about, oftentimes in learning, we're going to have rats or other animals press a lever, and they'll get some things will happen when they press the lever. Maybe they press a lever and they're no longer shocked, or they press a lever and they get a food pellet. A lot of the experiments that were done in learning follow this. So intensity is, how hard does the rat have to press the lever in order for it to work? If they barely have to tap it and it works, then that's a low level of intensity. Versus if they really have to push it down hard, that would be a higher level of intensity. Sometimes we use intensity to look at a Likert scale. So I'm sure many of you have participated in a survey where something is rated on a scale of 1 to 7. Like, how much do you like ice cream? Or how easy do you think general psychology was for you? On a scale of 1 to 7, 1, not easy at all, hardest class I've ever taken. 7, very easy, easiest class I've ever taken. So that's looking, and the person puts down either 1, 2, 3, 4, 5, 6, or 7. We're looking at the intensity that they have, how strongly they agree with that sentence, or how strongly they think that it was an easy class. So that's intensity. Speed, how long does it take someone to do it? So if I give you a whole bunch of multiplication problems and I ask you for the answer for each of them, and I do that same thing with a 3rd grader, I would expect you guys to answer the worksheet with the 50 multiple choice questions much quicker than the 3rd grader. With rats, how long does it take them to finish the maze? The more they've learned, the quicker it is to complete the maze. And you can look at errors, the fewer wrong turns they're going to make. So speed. Another thing is rate. So rate is the number of occurrences per unit of time. So do we do it fast or slowly, but also correctly? So it sort of combines errors and speed together, will give us rate. So many of you will end up using rate when you go to do your behavioral modification project. If you have something that you want to do less often, then rate is probably what you're going to be using as your dependent variable. Okay. So think about, how would you go about answering those questions that you wrote about for those 10 minutes just a few minutes ago, if you were going to use rate or intensity or what was the other one? I'm sorry, speed. And so some of you may have used that. When you look at the experiment that you design, you may have looked at speed, you may have used intensity. We have a couple more of these to do. One is fluency. Fluency is how correct you are in ratio to how incorrect you are. So fluency is a great measure to use when you want to know how many, when you want to get an idea of not only how good they did, but how good they did relative to how poorly they did. And latency, how long does it take for the behavior to occur? So once I put a rat in a maze, how long does it take them to actually get to the goal, go through the maze would be latency, how long it takes them to figure it out. So latency also can be like, let's say I show someone a multiplication problem. How long does it take for them to come up with the answer? Okay, so how long does it take for the behavior to begin, for them to respond to the response? If I give a rat a lever, How long does it take before the rat goes over and presses the lever would be another form of latency. So where speed tends to be once you start the behavior, how long does it take to finish it? Latency is once you're put in the situation, how long does it take for the behavior to occur? So, okay. So how would you measure the following with fluency and latency? What's the best way to learn to throw a football? What's the best way to teach math? You are answering those questions. How would you use fluency? How would you use latency? These are some of the questions you really want to think about. So as a study tip, of course, it's going to be really important that you know these really common dependent variable measures: error, topography, intensity, speed, rate, fluency, and latency. I think it's best that you not just memorize the definition that's in the book. I think simply memorizing that definition it will not let you know this information at the level at which you need to know it to succeed in the course. So what I highly recommend is that you come up with a definition of your own. You can use what's in the book, but maybe like add a little bit more and come up with an example. Hopefully the examples that you've come up with as we've been doing this class, I'm doing this quick lecture, will be of use to you. You can use them to help you know this information. Okay, that is it for this first video. We've talked about the 4 assumptions when we're studying learning. And actually, it's when we're studying any of the psychology, any of the social sciences. Actually, it's any of the sciences. But most people don't have a problem with those assumptions when we're talking about atoms or chemicals, like in physics and chemistry and biology. But sometimes people believe that those assumptions are not valid when we're talking about human behavior, and they may not be. So we can only trust the results that we're getting based on whether or not those assumptions are accurate. Okay, and then we've talked about common ways that we measure learning, and you'll want to know those. Okay, look forward to seeing you on the, well, I won't see you, but looking forward to you attending the second video for this chapter where we'll go through specific research methods.